Good morning, everyone. We're going to start here on notes 906, similar right triangles. Now, this is the activity page. I believe it's included in your packet. If not, just hear me out. We're going to go over some important vocabulary for today's notes. So we're going to start with a right triangle, and I'm going to situate it so the right angle is kind of up top, and the triangle is sitting on its hypotenuse. We have right angle at C is 90 degrees. We have AB down here being the hypotenuse. So that's the big right triangle we're starting with. If I were to label some pieces on this, we have a leg to the left, a leg to the right, and remember AB down here at the bottom is the hypotenuse. From there, we're going to draw in an altitude. Now we've constructed altitudes before, but right now we're just going to sketch it in. So from C down to the hypotenuse AB, we're going to draw in altitude CD. And I'm going to label it that the A-L-T. But what that's done is it's taken our big right triangle, where we have three sides, and it's broken it into three triangles total. So we have the big one, which is ACB. We have the one situated to the right, the medium-sized one, which is going to be triangle CBB. And we also have the one to the left here, triangle ABC. Now notice I put those in corresponding order, where C is the right angle in the big one, D is the right angle for the small one, and D is also again the right angle for the opposite one. Now a little bit more information they gave us was that angle B is 30 degrees. So when I put that in, now this triangle has a 90-degree angle, a 30-degree angle, and this little angle up top would be 60. The triangle to the left would have a 90-degree angle. The big triangle has right angle C, 30 here, meaning A would be 60, and we'd have a 30-degree angle up here. So these three triangles would be similar, again, by angle similarity. When we do draw that altitude in, we create three right triangles, and we have them drawn down here below. We have the large triangle, the medium triangle, and the small triangle, and we're going to find some patterns with the proportions we can kind of set out based on their sides. So in triangle ABC, being our large one, and triangle ACD, the small one, we can set up a proportion. Let's look at the hypotenuse AB compares to its side AC. And if we go to the small one, the hypotenuse here, since D is the right angle, remember AC is the hypotenuse technically, and that smaller triangle is to its corresponding side to AC from the first one is AD. So you kind of are going to notice a little pattern with each of these proportions we're going to talk about, that AC repeats itself. Now, in the big triangle, AB was the hypotenuse, but AC was a leg. Here in the small one, AC happens to be the hypotenuse and AD is the leg. So we're going to take advantage of these patterns coming up in our notes momentarily. If we go and look at the medium triangle compared to the big triangle. So ABC is the big one. Let's look at AB, its hypotenuse, right, corresponds to CB as the side of the large right triangle. CB would correspond to the side of the medium, DB. So again, we have this pattern where these two pieces are alike. And what we call this is what's called a geometric mean. Now for time purposes, I'm not going to look at the medium compared to the big for now. I'm just going to continue into the notes. So if we flip the page and look at the beginning of the notes here on right triangles and a geometric mean, what a geometric mean says, product of the means equals product of the extremes. So when we cross multiply, we get extreme times extreme, mean times mean. Now for us, the means will be the same. So we get an x and an x. At one cross product, remember, gives us x squared equals a times b. And then we could take the square root of each side, to get the square root. Now, since we're talking geometry, we're going to have only positive answers because we're going to be looking at measures within triangles. But typically when you do take a square root, remember we get the plus minus. Find the geometric mean of 12 and 4. So that means those are going to be our extremes, 12 in the numerator, 4 over here to the denominator. And again, the means are going to repeat. We get x squared equals 48. And we would take the square root and reduce our radical. 16 divides evenly into 48 3 times. So we would get here x equals 4 square roots of 3. Okay. So again, that's just reducing. Find the geometric mean of 3 and 27. We would have 3 as the numerator over x compares to x over 27. So again, that x repeats itself. 3 times 27 gives us 81. So we have x squared. The product of the means equals the product of the extremes. And we're going to take the positive value 9 as the answer with our square roots. So similar to triangles, we have what's called the PAAP rule that we're going to learn today. And in the right triangle, the altitude is the geometric mean between the lengths of the segments. So what we do is we call this, again, the PAAP rule, P-A-A-P. What that stands for is part, altitude, altitude, part. And how that corresponds to a proportion is that we have a part in the numerator. I'm going to say part 1. Over the altitude is going to be like our means. The altitude will repeat. And then the other denominator is going to be what's called part 2. So looking at the diagram here, the altitude rule, again, is used when we have an altitude or a measure next to the altitude CD. So if I put, let's say, a 8 here, I tell you the altitude measure here is 8. And the whole hypotenuse measure is what we're looking for. Okay. AD is going to be some measure x, an unknown. Oops, let me undo that. Sorry. I'm going to move where I put the x. We're going to put the x here to the right. I do know that AD is going to be 2 instead. So let's say I was given these 3 pieces of this big diagram. Now, remember, with right triangles, we can usually use the Pythagorean theorem, but these 3 measures aren't in the same triangle. The 2 is in the small little triangle, the 8 kind of is shared in both, and the x down here is part of the hypotenuse. So when we're looking at these pieces for the rule, part, altitude, altitude, part, the altitude measure is what the 8. So remember, 8 is your altitude. See that well, can you? 8, again, is the altitude. 2 is considered a part. Now, meaning part of the big hypotenuse. So 2, along with the rest of the segment, x, make up the entire hypotenuse of the right triangle. So 2 is part 1 for our purposes when we go to substitute here, and x is going to be part 2. Right? So when we do our proportion, we are going to put these digits in. So 2, again, is the first part. Altitude was 8, compares to the altitude again. So again, that 8 is going to repeat itself, denominator to the next numerator, and over x. So when we take the cross products, we get 8 by 8, which is 64, equals 2x. So I'm going to write 2x equals 64. Therefore, x is going to measure 32 for our first example. So the PAAP rule is used when you have the altitude. So looking at examples 1 and 2. Now we could almost redraw all the triangles each time, but this PAAP rule is a pattern of form. So labeling the 3 pieces that they gave us here, we have part 1, and a part meaning part of the biggest hypotenuse you see. So part 1 is going to be this 3x minus 22. Part 2 is going to be the x, meaning, again, part of the big hypotenuse. If we added those together, we'd get the 4x minus 22 if we needed it. And again, the 4 is the altitude. So we're going to use the PAAP rule, PAAP, for part is to altitude is altitude is to part. So substituting into the proportion, we would have 3x minus 22 is to 4, as 4 is to the other part, x. Cross product gives you 3x squared minus 22x equals 16. Subtract 16 from both sides, and then we'd look to solve the quadratic. So we have 3x squared minus 22x minus 16 equals 0. And our p's and c's, factoring, we would multiply our 3 times 16, which gives us negative 48. So our p value is negative 48. C value is negative 22, and we would continue going from there. So when we're in our table, if you go into your calculator, go to y equals, we do get that negative 2 and 24 are factors. Now those signs aren't going to work for us. So when we break this down, 3x squared minus 22x minus 16, we find that the product of A and C is negative 48. So now we're going to split the middle into the two factors that add or combine, to negative 22. So we have 3x squared minus 24x plus 2x minus 16. So again, I wrote our trinomial into now 4 terms, and we're going to factor by grouping. So the first 2 terms have a GCF of 3x that can come out. X minus 8 is left over. The second 2 terms we factor by group, and a positive 2 comes out, and again we're left with an x minus 8. So our little factors inside, after we factor out our GCFs here and here, these inside should always match. So continuing, we get 2 factors. We get 2 factors of 3x plus 2, which is we combine our 2 GCFs, and an x minus 8 equals 0. So our positive value of x is going to be 8. That's going to be one we keep. This factor here, remember, would become x equals, we subtract 2 over and divide by 3, so it's going to be negative 2/3. We're going to reject that anyway because it's a negative and we have value of x into our diagram. So for exercise 1, x will be 8. Okay. I'm going to set up exercise 2 for you. Again, we're going to use the PAAP rule here because there's a value next to the altitude. Now, sometimes it's going to be a variable, sometimes it's going to be a digit like exercise 1. But in this case, the 16 is going to be part 1. The 6 I'm going to use as the part 2. So we're going to say 16 is to the altitude, as the altitude is to the 6. Cross products gives us x squared equals 96. And we take the square root of each side to simplify the radical into the square root of 16 goes into 96 6 times. Those were actually the 2 numbers we just multiplied. So x becomes 4 square roots of 6. So again, that's your altitude rule. In order to find parts when you have a big right triangle with an altitude splitting the triangle into 3 similar triangles, the big one and the 2 small. The next rule is called the HLLP rule, HLLP, and the theorem here says the length of each leg of the original right triangle is the geometric mean between the length of the hypotenuse and the segments of the hypotenuse closest to that leg. So a reminder, the big triangle has 3 pieces. It has a leg AC, a leg CB, and again, the big hypotenuse AB. So here, there's not going to be a measure next to the altitude. So that's like our clue that we need this rule called HLLP. So again, H stands for hypotenuse, is to the leg is to the part closest. So I'm going to write closest down here to help out. Because this could be used for either leg. So the leg CB, if we had something next to that, or leg AC. So again, your big triangle has three pieces, the two legs and the hypotenuse. And that hypotenuse, when the altitude is drawn in, is broken into two parts. So we use this top part here, that AD would be used when we're trying to find leg AC, or we're given a measure of leg AC. And the other part, DB, would be used when we're trying to find leg CB. So if I put a few measures into the diagram here, and again, I'm just making these up to help set up the formula. I'm just going to take those words out because I'm going to run out of space. So let's say I had a measure of 8 for AC. So if AC, let's say, is 8, and AD is 2, and the rest of that hypotenuse, DB, is what I needed to find, X. Right? We could be using the leg rule. Again, we don't have anything next to the altitude, so we're not going to use that rule. We're going to use the leg rule. So we need to decide that the whole hypotenuse here, remember, is a measure of X add 2. So remember, we're adding these together. We're trying to find the whole hypotenuse. Because again, the rule goes HLLP. So the whole hypotenuse measure for us is going to be X plus 2. The leg, remember, is the measure 8 here. Goes in the denominator, and that repeats to the next numerator every time. And that leg, the closest part to that leg out of these two parts, meaning the 2 and the X, is the 2. So if we're looking for the leg 8 here, we're going to use this 2. But if we had the 8 down here, we'd be using the X. So we're going to put the 2 in the denominator. And our cross product is going to go 2X plus 4 when we distribute equals 64. Subtract your 4 over, divide by your 2, and you'll get X is 30. Okay, so that's subbed back in. The length of BD there would be 30, and the whole hypotenuse would be 32. Now from there, we could find the other leg using your Pythagorean theorem. So do not forget, we have right triangles. A squared plus B squared does equal C squared. Trying two quick examples, they tell us the whole hypotenuse here, AB, is, I believe, 18, is what I can see on my paper. The leg here is 6, and the part is X. Now, if we needed BD for some reason, which we don't in this case, but in the future, we might need to take 18 and subtract X if we had to do something, and we can do some subtraction after we set up a proportion. So try to keep your proportions simple as possible at the beginning here. But again, there's nothing next to the altitude, so this is the HLLP rule, HLLP. The whole hypotenuse is 18. The leg measure is 6. Repeats always. So again, you're only given 3 measures to begin with, but one will always repeat itself here in the proportion. And that's going to depend on its placement in the diagram. But the part closest to that leg is the X. So we'll have 18X equals 36, making X equal to 2. Now if X is 2, we could then find, if X was 2, then remember 18 is the whole thing, 2 is here, 18 minus 2 would give us dB to be 16. So sometimes you can go back in and find other pieces you need. For exercise 4, we have, again, the leg rule, because there's no measure next to the altitude. So since there's nothing there, we definitely need to use HLLP. So the HLLP rule says the whole hypotenuse, which in our case is going to be 20, corresponds to the leg X, as X would correspond to a part. Now we have 2 parts of this hypotenuse we just added together to get our 20. The part we're going to want is this 13, because it's closest with the leg we're finding. Cross multiply, we get X squared equals 260, and we would take our square root of both sides, and I'll tell you that 4 goes into 260 65 times. So 2 squared to 65 is going to be our final answer in simplest radical form. So again, to decide between our two rules, we have the altitude rule or the leg rule. If there's a measure like x next to the altitude, you're going to use PAAP. And if the measures are somewhere else in the picture, like x, 2, and 8 here, that would be the HLLP rule. So again, I'm going to go back to the other picture for a second. Sorry about that. So we have a 2 and an 8 there. The PAAP rule would substitute in as part 2 is to the altitude, as that altitude is to its other part, 8. The HLLP rule, if I have x not on the altitude here, but on the leg, the whole hypotenuse would be 10 compared to the leg x, as the leg x compares to its closest part, 8. So that's deciding between the two rules. If you'd like to try number 5 on your own, you're more than welcome. I'm going to scooch on to one of the other harder problems. So again, I'm going to skip ahead, just taking a peek at your homework. I know you're going to have one like number 10. So looking at number 10 quickly, find the value of x, y, and z. So each variable, we're going to have a new proportion to find. So let's start with x, go alphabetical. Now x is a leg. And we do have the measures of the whole hypotenuse. 9 and 7 give us the whole hypotenuse will be 16. So to find x, we are going to use the leg rule, HLLP. So the whole hypotenuse is 16, compares to my leg x, as x would compare to the closest part, 7. So 16 times 7, my apologies, my answer key isn't up to date, is x squared equals 112, and then you would simplify from there. Now moving on to help you find y. So in order to find y, that is an altitude. So to find the altitude y, we have the whole hypotenuse that's broken into these two parts, 9 and 7. So your altitude rule is, remember, PAAP, P-A-A-P. The first part is going to be 9 compared to altitude y, as altitude y compares to 7. And we'll have y squared equals 60. And we would simplify. And of course, that's going to be 3 radical 7, because we just took 9 times 7 to get there. We know 9 is a perfect square. I mean, same deal goes over here, right? So if we were to reduce this square to 112, didn't we just take 16 times 7? So we'd have 4 square roots of 7 in that case, because square root of 16, remember, reduces to 4. And if you're struggling with these radicals, please text me or email me, email me and let me know. I can try to individualize some review for each one of you as we're apart. So that's really it for the notes. This last one here, this word problem, I'm going to kind of skip for now. There will be some problems as you go through your homework that requires factoring. So just be careful as you set them up. I really want you to try them on your own first. Like if I were to give you a hint here back to number 5 as I'm just taking a peek. This again is the altitude rule, because we have something next to the altitude. So when we take this x over 2 rad 6 equals the 2 rad 6 over x minus 2, remember when you cross multiply here, you have to distribute. So we get x times x minus 2 equals 2 square roots of 6 squared, and x distributed in does give you an x squared minus 2x. And if you have a calculator, you can take 2 rad 6 squared if you'd like, but we like to expand it out. So 2 rad 6 times 2 rad 6 is going to be 2 times 2, 4. Rad 6 times itself, rad 6, is going to be 6. So our trinomial would read x squared minus 2x. This becomes 24, and we subtract it over. So we'll have minus 24 equals 0. So you will have a couple quadratics as you see on your homework. So if I just scroll to your homework for a minute, so you can see, it is a textbook page, so I'd like you to do the circle problems on separate paper. So like looking at number 15, that looks like an altitude rule to me. 16 would be an altitude rule. So remember, if the whole thing is 50, you might have to subtract to get one of your parts. So just looking at that quick example to help you out, you would need a 10 there for your altitude rule because you need the 2 parts in order to go into the PAAP rule. Another hint with this question 21, the Pythagorean theorem is going to help you to begin with. Remember that being an issue in the past when we've tried these questions. Do you have a 40 on one side, a 30 on the other, and you could find the whole hypotenuse. That measure in there is 32, but I believe you should be able to see that pretty good on your papers. The geometric mean came up at the beginning of our notes. So you can try 26, 28, 30. And as I said in our notes, we had one similar to these where you kind of need 3 different proportions to find your x, y, and z. So just know that I didn't finish one of the problems in the notes. I never went back to find x, z here. But once you know x, you could, again, use your Pythagorean theorem if that helps. Please submit pictures of your homework by Friday afternoon, and I'll make that clear in the notes. Thank you. Have a great day.